Hello everyone. Today we'll solve Jest 2020 Emt-Pyqs. Okay, let's solve it one by one. This is question number 1. Consider 3 infinitely long, straight and coplanar wires. 3 long coplanar wires, okay, and are placed parallel to each other. The distance between the adjacent wires is d. Each wires carry a current I in the same direction. Consider points on either side of the middle wire. Okay, current is going like this, same current, and consider a point on either side, that is R, and this is D, this is D, and the distance is D minus R. Suppose this point is here O, and this distance from that wire is D plus R. So, okay, according to question, consider the points on either side of the middle wire where the magnetic field vanishes. That means at that point the net magnetic field is vanishes. What is the distance of these points from the middle wire? Okay, sum over P net is equal to 0. Okay, as we know, magnetic field due to infinite long wire is mu naught I divided by 2 pi R. Okay, R. So, suppose this creates magnetic field B1, B2, B3, and due to this wire, magnetic field will be like this inward due to point is here. Okay, and magnetic field will be outward due to point is here by calling your hand and put thumb in the direction of current and call your hand, you will get the magnetic field at this point O. Okay, due to this, magnetic field will be outward as point is here. Okay, so B1 plus B2 plus B3 equal to 0, and B1 is equal to mu naught I by 2 pi D minus R plus mu naught, sorry, not plus, this is minus, because I am taking inward is plus and outward is minus. Okay, mu naught I by 2 pi R minus mu naught I by 2 pi D plus R is equal to 0. So arrange this because plus minus term, okay, and take common, all will be cancelled out. Okay, D minus R minus, sorry, 1 by D plus R is equal to 1 by R. So this will be D square minus R square D plus R minus D plus R equal to 1 by R, and D gets cancelled and remain 2R divided by D square minus R square is equal to 1 by R. So this will be 2R square is equal to D square minus R square, that implies D square is equal to 3R square. That implies R will be plus minus D by root 3. That's the answer, and here this answer is option D. Okay, let's go to the next question. This is question number 2. Charges are placed at here and here, that is plus q, and another minus q is placed at here and here. Okay, at a large distance, how does the electrostatic potential behave as a function of radial distance r from the center? Okay, first pause the question, pause the video, and try to solve by your own. And after that, check with solution whether it's correct or not. Okay, that will be beneficial for you. Okay, let's visualize the question. This is the origin and plus q. Here suppose plus q at a0, and another plus q at fourth quadrant, that is minus a0, and minus q at here, that is a minus a0, and another minus q at a minus a0. So connect this. To check the potential, we have to find first monopole, then dipole, then quadrupole. Okay, first monopole, sum over q is equal to q minus q plus q minus q will be 0. Okay, so monopole vanishes. Okay, then we have to check whether whether dipole vanishes or not. Okay, for the dipole, there is a simple method. We don't have to write each and all. In case symmetric case, this is a square, so we can draw like this. As in case dipole, the direction is from minus to plus. So dipole direction is this, and for this minus q to plus q, so dipole direction is this. So dipole are in opposite direction, so dipoles are cancelled to each other. So dipole is equal to 0. Okay, then we have to check quadrupole. Quadrupole is equal to sum over q into r square. You have to check all this, and that will be vanishes. Obviously that's vanishes. Okay, sorry, that will not vanish. Okay, so our potential will be proportional to 1 by rq. As if dipole vanishes, if monopole vanishes, potential will be proportional to 1 by r. If dipole vanishes, potential is proportional to 1 by rq. One by r square. If sum over q remain, then the potential will be this. If sum over p does not vanish, then v will be proportional to 1 by r square. If sum over quadrupole not vanishes, so potential will be proportional to 1 by rq. Here q and p vanishes, so this will not. This will be the proportionality. Okay, let's go to the next question. This is question number 3. A ring of radius 0.5 meter has a gap of this is gap, suppose that t is 0.002 meter. If the ring carries a charge 1 coulomb, and distributed uniformly along it, then the electric field at the center of the ring. As electric field due to ring is 0, but in here the electric field will not be 0 because there is some gap. So how we can find? As you know, according to as we know, electric field will be due to this remain. Okay, so d is equal to k dq by r square, and dq is equal to lambda dr due to line charge distribution. Okay, and lambda is equal to q by 2 pi r, and dr k by r square q by 2 pi r. Sorry, this is the whole radius into df. This will be 1 by r square electric field due to ring. Okay, r, and it will be the full r, k by r square. Only dq changes and all other things are constant. That's why electric field changes due to dq. Okay, so dr, integration of dr. So integration of dr, and this dr is this. Okay, so q by 2 pi r cube, and that is 0 to t, thickness t. Put the values. Q is 1 coulomb into k is 9 into 10 power 9 and divided by 2 into 3.14, and r cube, r is 0.5 whole cube into t is the thickness is 0.002 So by solving all this, we will get the answer is 7.2 into 10 power 7 Newton per coulomb. Okay, this is option B. Don't write it R. Suppose it's like T. This is the thickness. So that will be easy to simplify the question. Okay, T. Let's go to the next question. Two rails of a rail track are insulated from each other and from the ground. Okay, and are connected by a millivolt meter. What is the reading of the millivolt meter when a train travels at a speed 90 km per hour? Okay, assume that the vertical component of the Earth's magnetic field is 0.2 Gauss and that the track are separated by 2 meter. Use 1 Gauss like this, and you know this is the EMF will be VLB, as this is the motional EMF. Put the values and you will get 1 millivolt. I am not going to solve this because it's very easy question. Okay, let's go to the next question. What is the charge stored on each capacitor C1, C2 in the circuit shown in the figure? Okay, first this is the DC voltage. So by applying DC voltage, capacitor will be open. So circuit will be like this. 6, 3, 3, this is 12, and apply KVL, and this is current I. By applying KVL, 12 minus 6i minus 3i minus 3i equal to 0, so I will be 1 ampere. As this is connected in series and this is also connected in series, so the voltage developed across this series combination will be equal to this, because both are connected in parallel, so voltage developed across this will be voltage developed across this, so R equivalent will be as connected in series, so 6 plus 3 is equal to 9 ohm. 6 plus 3 will be okay, but we don't have we don't need R equivalent actually. We get I, so voltage developed across 6 will be 6 into 1 is 6 volt, and voltage developed across 3 will be 3 into 1 is 3 volt. So C equivalent will be as connected in series, so C1 C2 divided by C1 plus C2 is equal to 2 into 1 divided by 3 is equal to 2 by 3. So as you know, Q equal to CV, charge stored. So Q1 is equal to C equivalent. Its corresponding voltage is 6. Okay, and its corresponding voltage is 3. So 6 into C equivalent 2 by 3 into 6 is equal to we have to take R equivalent also. So R equivalent is equal to 6 plus 3 is equal to 9. So this will be 9. This is 2 into 3 is equal to 6 volt. And Q2 will be C equivalent into V also, total voltage. Total voltage equal to 9. So this total voltage is equal to 2 by 3 into 9 is equal to 6 coulomb. This is coulomb. So answer is 6 and 6. Option A. This is another question. 3 polarizers are stacked normal to a central axis. 3 polarizers, suppose this like this. This is the transmission axis. This is transmission axis. And this rotated. Okay, the first and the third polarizer are perpendicular to each other. That means first polarizer transmission axis this, and second and third will be T3 like this. So the middle polarizer is rotated at an angular frequency omega. This is omega. about the central axis, the time dependent intensity of light emerging after the third polarizer. So we have to calculate time dependent intensity of the third polarizer. Okay, and its transmission axis will be this T3, and the angle in between previous transmission axis. If this is omega, this will be 90 minus omega t. We always take the angle between the presence transmission axis with the previous transmission axis. So this is 2 and 3. First, second and third. By using Mallows law, I equal to I naught cos square theta. So when unpolarized rays are coming, that fast transmission axis will give the average intensity is equal to I naught by 2. So I is equal to I naught by 2, and I2 will be I1 cos square omega t. So this will be I naught by 2 cos square omega t, and I3 will be I2 into cos square omega t. This will be not omega t, 90 minus omega t. Okay, I2 is equal to I naught by 2 cos square omega t. Cos square 90 minus omega t will be sin square omega t, and that will be equal to I naught by 2. This 4, 2 square sin square omega t cos square omega t, and is equal to I naught by 8. Should be sin 2 theta sin square 2 omega t, and question answer is not in this format, so we have to solve further. That is I naught by 8 sin square theta is equal to 1 minus cos 2 theta divided by 2. So this is equal to I naught by 16, 1 minus cos 4 omega t. This is the answer. And this is option A. Okay, let's go to the next question. A thin film of water having refractive index n is equal to 1.33 floats on the surface of a beaker of silicon oil. Okay, and NS is 1.4. Orange is illuminated by 600 nanometer light incident normally from top, and a large region of the film appears bright red. Okay, what is the minimum possible thickness of the film? Here it's very simple. Suppose this is the thin film. This is the thin film, and refractive index of this film is 1.33, and it's floating on oil, and oil refractive index is given 1.4. So, and incident wave is normally incident. That wave is equal to 600 nanometer. Okay, and appears bright red. What is the minimum possible thickness? As you know, there is no case of reflection, so no extra term will come. So total 2 mu t cos r is equal to n lambda for bright fringes or for constructive interference. Okay, for constructive. In case a thin film, but if reflected, if the ray will be reflected, then extra term will come. That will be 2 mu t cos r plus lambda by 2 equal to n lambda. But this is not case. This is a case where there is no reflection. So 2 mu is equal to 1.33 into t we have to solve, and this will be 1 because r is equal to 0. As we take the theta from here, so theta is 0 and lambda is given 600 nanometer. So dt will be a thickness, and that will be 225 nanometer. This is the answer. Okay, let's go to the next question. A ledger has output power is this with beam diameter is this at wavelength. What is the value of electric field by using Coulomb constant? Okay, this is the case of power is given 150 kilowatt and diameter given, so radius will be 1 millimeter and wavelength given and electric field. As you know, Poynting vector is equal to half c epsilon naught square. So E will be 2s by c epsilon naught root over. That is the electric field. And please wait 1 minute. Okay, this is the Poynting vector, but here power is given. As you know, Poynting vector is equal to power per unit area is equal to half c epsilon naught square. This is the form if Poynting vector is given, but here power is given, so we have to calculate E is equal to 2p divided by a c epsilon naught whole root. So put the desired given values and you will get, and its area is equal to, as this is the case of ledger, so area will be pi r square, cross sectional area. So put the values and you will get the answer is equal to 6000 volt per meter. Okay, one more question left. that is this question. An electric field is given by this. Okay, here theta is our step function. That step function is, if the value is x greater than 0, then value will be 1, and if x less 0 or equal 0, that step function will vanish 0. Okay, the corresponding charge density and the current density are given by. Okay, electric field given, we have to find rho and j, and magnetic field 0. So as we know, from Maxwell's equation, divergence of electric field is equal to rho by epsilon naught. So rho will be epsilon naught divergence of electric field, and epsilon naught divergence of electric field is, for the sake of convenience, let's take it k. Okay, k, q, and minus sign is also there, minus divided by r square, and theta vt minus r and r cap. At k and q are constant and there is no dependency of t and r, so take common, minus k q epsilon naught r, and divergence of r cap by r square theta vt minus r. Okay, okay, let's solve this. As we know, by divergence property, this is constant and this is a vector, as r cap will be r vector by r cube. Okay, and divergence of a constant and a vector will be like this, minus k q epsilon naught theta common, theta is the step function, vt minus r, divergence of r vector by r cube, plus r vector by r cube into grad of theta. Okay, then this will be minus k q epsilon naught, and this is the delta property, delta qr will be this. Okay, theta vt minus r into delta qr plus, and grad of delta function is equal to grad of step function is equal to also a delta function. That delta function will be theta vt minus r, and minus 1 common because here is minus 1. Minus 1 take count. Okay, and keep minus sign inside, so our answer will be, and again keep this like r vector as r cap. Okay, so by arranging minus q and epsilon naught divided by 4 pi epsilon naught cancel, and that will be delta q r theta vt minus r, and minus plus, and this will be r cap by 4 pi r square delta theta. Sorry, derivative of this will be not theta count, that is only delta Vt minus R, which is matching with option T. Okay, not with anyone. This only due to this factor. Okay, but we can find also J. Let's go to the next slide. As you know, P vector is equal to 0 given in question, and by fourth condition of Maxwell, del cross P is equal to mu naught J plus mu naught epsilon naught del E by del T, and this vanishes, so we have to find J. So J will be minus epsilon naught del E by del T. So minus in case electric field, put that electric field 1 by 4 pi epsilon naught into Q by R square. The only time dependent term is step function, that is Vt minus R cap. So that will be Q by 4 pi R square, and the derivative of theta will be delta function delta Vt minus R and d by dt Vt. So this will be minus Q P divided by 4 pi R square delta Vt minus R. This is the answer. This is J. Okay, let's check. Okay, this is the option D. Okay, our questions are over. So thank you. Keep learning, keep watching, and please share and keep watching. Thank you.